Welcome to Spring Lib.
In this question, it is given that a uniform meter stick is suspended from the ceiling through two vertical strings of equal length, and a small object of mass 20 gram is placed on the stick at a distance of 70 semi from the left end. Now we have to find the tensions in the two strings. So first of all, I am drawing the diagram for this given question. So this is the ceiling, and these are the two strings through which the meter stick is connected. This is our meter stick. Now we have given that a small object is placed at a distance of 70 semi. Let this distance is given to us, which is 70 semi. Now I am showing all the forces acting on this system. First, the weight of this meter stick that is acting at the center of this meter stick, that is, let m1 into g, and this is m2 into g, which is the weight of this block. Let the tension in this spring is T1 and tension in this spring is T2. And so I am writing here all the given data, that is mass of the meter stick, that is m1 is 200 gram, mass of the block, that is m2 is equals to 20, and length of the string, that is L, is given to us, which is 1 meter. Now we know that as the system is in equilibrium, so the net torque about O will be 0. So net torque is 0 about this point, that is O. So writing the net torque, so torque due to this tension is T1 into R1, which is into anti-clockwise direction, and torque due to this tension force is minus T2 into R2, because this is into clockwise direction, and torque due to this is 0, and torque due to this weight is minus m1g into R3. R1, R2 and R3 are the distances of these forces from this point, that is O. So R1 is 0.7 meter, R2 is 0.3 meter, and R3 is 0.2 meter. Now put all the data in this equation. So from here we get T1 into 0.7 minus T2 into 0.3 minus mass is given to us, that is 2 into 0.2 into G. This will equals to 0. So from here we get 7T1 minus 3T2 is equals to 3.92. Let this is equation number first. Now one more equation we have to use, that is total upward force will be equal to total downward force. So the total upward force is T1 plus T2, and the total downward force is M1G plus M2 into G. So from here put the value of M1 and M2, we get T1 plus T2, that is equals to 2.156. This is our equation 2. Now we have two equations and two unknown. So after solving equation 1 and 2, we get T1 is equals to 1.038 Newton, or I can say 1.04 Newton, and T2 is equals to 1.18 Newton or 1.12 Newton. So this is the tension in the both the strings, and this is our final answer. Thank you.